Morning. Today we discuss about a very important topic for the physics students, which are studying in BSc third year physics honors and in sixth semester. Okay, and topic is nanoscience. What is nanoscience? Nanoscience, and it is a very new science to the scientific world, and the word nanoscience, what it means by nano. Actually, nano word is derived from Greek word, nanos means nanos. What is mean nanos? Dwarf, bon admi, dwarf. Okay, it means nanoscience is related to those particles and their behavior and their properties whose size is very, very, very small. Actually, nano size refers to what? 10 raised to power minus 9 meter scales. 10 raised to power minus 9 meter scale. Those particles, those structure whose size is near or equal to 10 raised to power minus 9 meter, then whole science, their properties, their behavior, their application, their phenomena are in the jurisdiction of what? Nanoscience. And it is very important. How it is important? Let us see. We know that DNA size is about 3 nanometer. RBC size, red blood cell size, 6000 nanometer. And also very important tools which are today providing many interesting and fruitful scientific applications. CNT tubes, carbon nano tube. What is the size of this? Diameter of CNT tubes is also about 3 to 4 nanometer. So we need a very accurate science to explain the behavior of very tiny particles. If anyone asks what is a nanoscience, how will you define? Actually, we have to define in a scientific way and in a periodic manner, such that nanoscience is the study of nanoscience is study of what? Structures, materials, particles, particles which are lies on the scale of 1 to 100 nanometer. Very important, 1 to 100 nanometer. This is a scale. If any particles, any structure whose any one side is lies in the range of 1 to 100 nanometer, then the structure behavior, particles behavior is lies in the jurisdiction of nanoscience. Okay, understand it. In the other words, we can also define nanoscience as nanoscience is study of phenomena and manipulation of materials at atomic, molecular and macromolecular scales. Okay, let us again define nanoscience is the study of phenomena and manipulation of materials at atomic, molecular and macromolecular scales. Okay, what is this macromolecular? You are very you are very familiar with atomic, molecular, but are you familiar with this word macromolecular? Actually, it is polymer structure. This is very important in today's world because you should know that about 70 to 80% materials of today's world is from polymer materials. Your polythene, chair, and your washing machine, and so many things which are where the word sustain poly means many. Okay, so nanomaterials are also defined as a materials which have structured compared with a size less than about 1 to 100 nanometer in at least one dimension. And you know why it is so important. Okay, if we change the size of particle, from large to nanodes, then the behavior of material made up from these particles change dramatically. Dramatically. Some of the examples, some of the examples that we we saw in the scientific world, that if we change the size of the particle from large to in the scale of nanodes, then there is a dramatically change of materials properties if we transform a particles from bulk to nano. I use a word here, bulk. What is meant by bulk? A material is said to be bulk if the dimension of the structure, if none of the dimension of structure or materials is comparable with the de Broglie wavelength of electron or Bohr radius, then the particle is said to be what? Bulk. It means if size of particle size is a different word, dimension. Use the word dimension so that it may relate to spatial properties also. If the dimensions of structure material is, if the size of if dimension of structure of material is not comparable, or in another words, if none of the dimensions of structure oblique material is comparable with de Broglie wavelength or Bohr radius, then material is treated as what? Bulk. So you are now familiar with what is the nano size and what is the size of bulk. Okay, and whole nanoscience is related with the definition of this size dimension. If I change the the dimensions of the particle which is responsible for the properties of the materials, then there is dramatic change if we change the dimensions from bulk to nano. For example, solids can become liquid at room temperature if we reduce the size. Gold is the best example of that. Insulator can become conductor. Silicon, stable material, can become combustible like aluminium. Okay, so you are very familiar with the importance of these structures which are formed by the particle having a dimensions in the range of what nanoscale. So on the based upon the work conducting so far in this field, we can say that nanoscience is an emerging area of science and technology and is a diversified field with very wide applications. Today, uh, the principles of nanoscience are used in medicine, energy, computing, and memories for information, CNTs, and so many science. Okay, then which science is which uh, part you have to which field or you have to which uh, one of which area is is in the mother of this science. You can say that quantum mechanics. What? Quantum mechanics is mother of nanoscience. Why? Because this science, quantum mechanics science, phenomena, laws, and applications are based upon the which particles having the dimensions of atomic scale and up to what? Up to if we go towards quantum mechanics to classical mechanics, then size is always going to what? Increases. So quantum mechanics is the mother of this science. And you know from where this birth takes place. Nanoscience idea of nanoscience is based on famous physicist Feynman lectures in 1959, and he said a famous note. What is his famous note? He said that there is plenty of rooms at the bottom. फेमान ने क्या कहा? रिचर्ड फेमान said, what he said, there is plenty of rooms. There is plenty of rooms at bottom. What it means? He says that if we reduce the size of the particle, we may find some interesting properties. If we break down the size of particles, then the material gets some dramatic interesting properties. And if you go in the back, you find that Our forefathers also familiar with this nanoscience. In ancient India, around 600 BC, we find some evidence from the woods, steels, and also some structures which contains nanoparticle are also found in Mesopotamia, and one of the mm, famous article which is based upon this nanoparticles is a cup which is uh, which is placed in the British Museum, which is placed in the British Museum at London. And the most interesting properties of this lycoscope is that it changes its color from green to a deep red when a light source is placed inside it. Very interesting properties. It means this is change of wavelength, there is change of frequency if we reduce the size of the particle. So on the based upon Richard Feynman lectures, there is a plenty of room at the bottom. Many scientists do very hard work, and many after manipulations and very hard work, one of the famous scientists who may be called as a leader of nanoscience is Japan के one of Japanese Japanese scientist whose name is Norio Taniguchi. In 1974, he published a paper about this nanoscience. This science is idea on based on this man, but is separate science from today's science. The birth of nanoscience as a separate science. The birth of nanoscience as a separate science was the result of hard work of this Japanese scientist Norio Taniguchi. Norio Taniguchi. Okay, and after that, so many scientists like Drexler and so many scientists do very hard work in the field of nanoscience, and the speed of this nanoscience get new dimensions after discovery of STM. What is STM? Scanning tunneling microscope. Scanning tunneling microscope. Who invented that? Gerard being geared. Okay, it is it was same spelling. I'm just forgotten about the spelling. Binning, Gennard Binning, STM in which year? 1981. And also discovery of fullerene, carbon 66. In which year? 19. I think yes, 1985. By which it's also a Japanese scientist. Kuroto. These inventions gave new dimensions to the nanoscience. Why? After by the use of these instrument we can study, and we can even see the properties, and we can scan all these properties like their conductivity, their morphology, their hardness, and their internal structure. Is there is any possibility of the movement of the particle between the layer of molecules or atoms? So if we study these nanoparticle based materials, and it is only done on the basis of one of the most scientific discovery in 1981 by Gerd Binning, STM. It is one of the very important discovery, and he got a Nobel Prize for that. Okay, and okay, if we if we try to get a material which is based upon nanomaterials, then there are two properties, then there are two ways, two paths or ways to form nanostructures. One of them is top down and another is bottom up. Okay, so it is all about the nanoscience. Okay, and in next lecture we will study about nanotechnology. Okay, this is all about the nanoscience, and you will study, you will get the topic or new information about what is the implementation of nanoscience, which may be called as the body particle word nanotechnology. In the next lecture, goodbye, thank you very much.